this right here is called an inequality, right? And this guy over here is a quadratic. I'm taking a quick glance here. Sometimes you might get a higher degree, like a polynomial with a degree of 3. But the point is, you guys don't know what the heck you're looking for. Like it's like a visual thing. If I were to graph this, I know it's a parabola. So it would look something like this, right? It would go up like that. But do you guys, those of you guys who graphed it, can you guys tell me what the x-intercepts are really quick? So what you can do, I guess, you could solve this and find, like, you set this equal to 0 and solve it like you normally would to find your x-intercepts. You guys can also do on Desmos, which is what Nareda just did. She did on Desmos, and she can see that -4 and it's like 0.66 something. Those are your two x-intercepts. And I'm drawing a rough sketch. It doesn't have to be perfect. I know it goes up because it's positive. And so that's what the graph kind of looks like. And you don't have the graph to do this, but I'm just saying, if you see the graph, it makes a lot more sense for what this is asking right here. You can say that this is f of x. So f of x is less than or equal to 0. It says f of x is less than, what is f of x? Y. That's y. Where is y less than 0 on this graph? Because this right here is f of x. That's the graph of f, the f of x, the line right there is f of x. Where is that less than 0? You guys see it? It's everywhere right here, right? Wherever it's below the x-axis, it's less than 0. So what you really have going on here is you have 3 intervals of answers. It could be this interval, it could be this interval, or it could be this interval. Notice how they're on every side of the x-intercepts. Does that make sense? Because honestly, you're not going to graph this every single time. There's actually a slightly faster way. You could just draw the x-axis, and you can put on that x-axis, just randomly, it doesn't have to be perfect, your 2 x-intercepts. So this is my x-axis right here. What did you say it was? 0.66 or something like that? Yeah, 0.6. Oh, okay, so it's like, it's 2/3. Okay, so these are my 2 x-intercepts for this graph. Now, we're going to pretend we don't know what this graph looks like, and we just have this. How would you know where the y is less than 0? Like, if you're just looking at this, how would you know where the y is less than 0 without having to graph it? Oh, not max and min. Plug in points. That's it. Can you guys give me an x value below -4? Yeah. You can take -5 right here and plug it in. Can you guys give me a value between this one?
0.
Yeah, 0. Thank you. 0 is probably right about there. There's 1 right there. And then give me a value that's above this one. 1. Okay. If you take these values and test them, you can see if it's above the x-axis or below the x-axis. How would I know if the line over here on this side, without looking at the graph, we're pretending we don't know what the graph looks like, how would I know? Like, what would my result be that tells me that it's above or below the x-axis? If it's true or false, or positive or negative. It's up to you. So let's go ahead and plug in -5 right here. That might be kind of big. -5 squared, we're going to multiply it times 3 plus 10 times -5 minus 8. What do we get right there? That's going to be a positive 25, and times 3, that's going to be a really big positive number, right? If I multiply this, really big positive number. And then right here, I'm going to get a negative number. That's going to be -50. What's going to be bigger, the 3 times 25 or the -50?
25.
Or, yeah, the 3 times 25, right? Actually, that's 75. That's not that big. So we have 75, -50, and then we have a -8. Are we going to be positive or are we going to be negative?
Positive.
We're going to be positive. And so I would write something like this just to remind myself that's positive right there. If I plug in a 0, oh, I love zeros. That's gone, that's gone. I'm left with a -8. Is -8 true right here? Is it -8 less than 0? Yeah. We have a negative right there. And then right here, we plug in 1. That's going to be positive. and I'm kind of cheating now because I know what the graph looks like, so I know it's going to be positive. So here, because it says less than 0, we know that wherever it's negative, that's your answer. So what's my answer here? The interval, -4 to 2 over 3. Now I have a question. How do you know if it's going to be parentheses or brackets? This guy right here. You see that little line right there? If it has an equal to, then you know that it's brackets. Make sense?
Yes.
Okay. The other intervals, just so you can see them, the interval right here would be 2 over 3 to positive infinity. And the interval right here would be negative infinity to -4. Okay? Now, this interval can be written in a different way, like this answer. And I want to show it to you guys really fast. It's called set builder notation. You write it like this. You put little. You're going to use squiggly brackets. We're going to go x such that x is greater than -4. I kind of look at this line to kind of think about it. It's this interval, so it has to be greater than -4, and it has to be less than 2 over 3. Then you use your squiggly brackets. Okay. Is it okay to combine it? Yes. Oh yeah. You can write it as x. I don't think that it's normal. I don't know. Let me look into that. But it makes sense to me that you would combine it. You put -4 here and 2 over 3 right here. It has to be less than 2 over 3 and greater than -4. Or equal to, right? Oh, I almost forgot the equal to stuff. But this is interval notation. That's set builder notation. It doesn't matter which one you choose, unless the problem says write it in set builder notation or write it in interval notation.